in today's tutorial, we are going to look at cross product, scalar triple product, those sorts of things. Now, in last week's tutorial, I actually did some other algebra-related questions, but this chapter is a very long chapter, and I'm quite glad that we did talk about some of those questions last week, because it leaves us more time to discuss these things today. So let me share my screen with you, and we can have a look at some of the questions. Okay, and then we can talk through them together, and I'll get your help on that. So you should be able to see my screen now. This is page, let's see, it's chapter 2 it is today. Page 74, and I'm going to start at question 10. Now, believe it or not, the recommended problems are the entirety of the chapter 2 problems, which I think is pretty crazy for today. So actually doing some of these problems last week. Daran, we're doing algebra today. So last week I did some algebra and people said, oh, maybe we can do some calculus as well. But there are recordings last week of the calculus in case you missed it. Hope that makes sense. So I'm actually going to start with question 10 today. And this is a common type of question. And I'll do part A. Part B is very similar. But students tend to find these quite challenging because there's quite a lot of steps involved. But for me, the most important thing is to draw a picture. So let me share my document camera and we can get down to it. Okay, so let's write out some of the question. I've got new pens today as well. I'm using Sharpies. So let me know what you think of my writing. I know in the past I've used these German brands, but I'm onto Sharpies today. So, all right. So this is question 10. And before I write out all the stuff, let me just draw a little picture, because I think pictures are very helpful when it comes to working out and understanding the problem. So you've got a line and you've got a point B that's not on the line. And what this question is asking you to do is to work out the distance, the minimum distance from the point B to the point on the line. So you've got a little perpendicular line segment there between this point and this point. Okay. Now, in these kinds of questions, you also usually have a point A on the line and you have a vector V that is parallel to the line. Now, in this picture, the vector V is pointing this way. Of course, it could point the other way. So that's no problem. And what we're asked to compute is the length of this vector here. Okay? That's really what this question is asking us to do. So this is part A. All right. So the easiest way to do this is to realize that this is just a right-angled triangle. Okay? So what you can do, you can say, well, I know by Pythagoras, I know that there's a connection between the lengths of the sides, right? So all you can do then is switch that around. Okay, you know that this length is this. Okay, so pretty easy so far. We know Pythagoras from high school maths. We know what B is from the question. We know what A is from the question. So this is easy to calculate. The only thing that's not easy to calculate is the vector AP, because we don't know what P is. So in the chat on a 9 a.m. it's in Sydney on a Monday morning, week 4, how might we calculate the vector AP? Does anybody know? Or even the length, right? All we really need is the length. Can someone smash that chat button on a Monday morning? Let me know. All right, it's coming in. All right. Zikri says ratio, Justin, projection, Zach, projection, Julia, projection, Ben, projection. All right, well, I think you're all pretty much on the right track there with the projections. So let's have a look. If I look at the vector AP, that's just the vector projection of AB on this V vector. Okay, that's kind of how we define the projection of one vector on another. So that's what it is. And if you were to write that out in terms of dot products and lengths and stuff, it's this times a unit vector in the direction of V. Now, I'm sort of breaking the rules there by dividing, but this is just the vector multiplied by 1 on its length. Okay, so if you just want the length, it's pretty easy to do. I just take the length of that, that's 1, so that's it. Okay. So remember, the top here is absolute value and the bottom is length. So let's work this out for our question. So in our question, we have A is the point 1 to -5. B is the point -2, 1, 5. Yep. And our vector V, which is parallel to our line, is given by 6, 3, -4. Okay, so we understand the setup here. Let's actually put it down to a proper problem. Okay, so to compute, well, we need to get AB. We need to get the length of AP. We can do that up there, and then we'll work it all out. Okay, so first things first. Let's compute AB. Okay, so the vector from from the point A to the point B is the position vector of that minus the position vector of that. So you just work component-wise, right? So it's going to be -2 minus 1, 1 minus 2, 5 minus -5, which is that. Okay, so that's that. Or V is just there, so I won't write that down again. Now let's compute, we need a length of V. So you square the components, add them together, and take the square root. Okay, so 36 plus 9 plus 16. Okay. Now let's work out this length here. And we need to work out this length too, by the way. So I guess it's pretty easy. All we need is the square of the length, really. So it'll be 9 plus 1 plus 100. Okay. And lastly, we'll get onto this now. So let's let's compute this. Okay. So the dot product of AB with V. So we want to dot product this vector with this vector. So how do you do that? Well, you multiply the components and you add them together. Okay, so it'll be -3 times 6 plus -1 times 3 plus 10 times -4. Okay, all over the length of V, which is √61. Okay, if you work this out, you get √61 up the top. Okay, so now we've got all our machinery. We've got this, and we've got this. Okay, we want to put that into there, so we'll square this. Okay, so maybe that's a slightly nicer form. Okay, let's put these in here. So that'll go in there, that'll go in there. You look at the difference, and you're going to get the square root of 49. Okay, so it's going to be 110, whoops, minus 61, and we get 7. Okay, so what is that saying? Sorry, Paul, where did I make a mistake? Should be A plus. Where are my people? Help me out. Why is there A? Oh, yeah, thanks, just here. Sorry. I'll put a little smiley face in there. Thanks, folks. Thank you. Thanks, Osmond and Paul, and good job. So that's a plus there, of course. Thank you. No smiley face required. Okay, so what does this actually mean? It means that the length of that vector there, or that distance, is 7 units. Okay, so it's 7 units. Now, quite a few students, when they see my solution, they go, "Oh, Professor, do I need to write all this down?" And the answer is no, you don't need to write all that down. When I'm doing the problem, I'm kind of explaining it as I go to you. So I write a lot, okay? But there are important ideas going on in my solution. So let me just show you one more time. Okay. What a lot of students tend to do is they tend to memorize formulas. Okay. Whereas if you just draw a picture and use Pythagoras, it's super easy to really understand what's going on. Now, here's my question for everyone. In this picture, right? With this V, is my V really pointing in the right direction that's consistent with this V? And how do you know? Okay, this is like a slightly higher level question. I know it's still early in the morning. Does anybody know, does the direction of that V really reflect this V here? And how do you know? Does anyone know? Rahul says no change in the answer. Right, yep, you're absolutely right. I guess what I'm asking is, the way I've drawn this V, is that really accurate it when it's this particular V here? And you're right, there's no change in the answer. But I mean, really, if I was drawing this V accurately, it would be pointing the other way. Why? Because the dot product here, the dot product inside here is actually negative. So you know the angle's got to be bigger than 90. Anyway, just a small thing. Just a small thing, not super important. All right. So that's a little bit about minimum distances. And these are, you see these kind of questions all the time. Now, part B is very similar to part A. The only difference is that you have a Cartesian form for the equation of your line. Okay, so there's not a big difference. It's just, okay, well, you need the point A and the vector V. So who can tell me in the chat, in part B, what's a point on the line and what's a vector that's parallel to the line? So what would an A point be and what would a V vector be? Who can put that in the chat? Matthew, yeah, you can't. I can't draw it in 3D. But did someone say GeoGebra? All right. Dharam and Rahul are on the case. So 1, 2, 3 might be a point on the line. And what about a vector V that's parallel to the line? Who can put that down? Yes, Matthew, I like your style, mate. Thank you. So you would just run the same calculations as we did in the previous part A question. Okay, so I won't do that today. All right. So let's move on to cross products. Now, when some students see the cross product, they think, oh, this product must be angry because it's a cross product. Sorry, bad math joke there. But I guess the important thing here is to understand what the cross product is and how to do the calculations. Okay, so let me share the PDF. All right, so we're moving into 2.4 now. Okay, so the cross product, it's not angry, it's not an angry operation, but sometimes it does make students angry, right? So this looks like multiplication sign. It's not proper multiplication. It's a special kind of operation. Thanks, Dharam. I can feel the love there. And what it does is geometrically, you start with two vectors and you do an operation on them and you get a third vector that is perpendicular to the first two vectors. So that's a lot of stuff. Let me show you. Yeah, I know, Marley. I know it does make some students go grr, that's for sure. So let me share. Did somebody say GeoGebra? Okay. So here it is. Okay. So here's a point, 0 to -4. Here's another point. So you can see them in three-dimensional space. And let's draw position vectors to those points. Okay. And now, sorry, I don't want to make you dizzy. And now I'm going to come back. Okay, that's better. All right. And now I'm going to do the cross product. Okay. So what does that third longer vector actually mean? Well, I'm glad you asked. Okay, so A and B, let's look at A and B for a second. I'll put the plane in containing A and B and also going through the origin. Okay, so now you've got a plane that is containing, I guess it's parallel to the vectors A and B and it goes through the origin. So basically it contains the vectors A and B. And what can you see between the normal vector, the long vector, and the plane, it's normal. It's normal, perpendicular to the plane, okay? So that's the geometric explanation of what you get when you cross two vectors together. Now, let me just show you something. I think I'll do it here. I'll do the cross product the other way around, right? So let's do B cross A. Oh my goodness. Now the vector's pointing in the opposite direction, okay? So the order does matter. The order does matter when you do cross products. A cross B is not the same as B cross A, right? They're equal up to a sign, up to a negative sign. Okay? All right. Did someone say GeoGebra? Yeah, yeah, Marley, I know Desmos. I know there's a strong Desmos crew here. Maybe I'll pull out Desmos a bit later. Okay, so let's go back to the question. Okay, so I'm going to do part A. So you've got two vectors and you just want to find their cross product. We already know what it's going to look like from GeoGebra and maybe from Desmos too, if you do that. Okay, so let's do it. Now the focus changes from what does it look like and what does it produce to how do you actually compute it, you know, using a Sharpie or something or whatever, right, in your head. So let me show you that. All right, so I'll go back to my document camera. So this is 14. A. So let's write down these two vectors. So remember, I put these little squiggles or tildes underneath to denote boldface, right? Because you can't write boldface, even though I see some nice boldface in the chat. Okay, although if you watch Khan Academy videos, he's there trying to make this boldface with this huge thick marker. Yeah, I don't know if that works for me. Okay. All right, so as many of you know, I used to lecture this course, right? But I have seen some lecturers do this a little bit differently when they want to do this. So the way I do it, and it's up to you, whatever you use, I write this as a determinant. Okay, so let me know if this is familiar or a bit weird. Now, I think in some classes, the lecturer writes the ijk vectors as the first column, right? I do it as a row. Okay, it doesn't really matter. Okay, and then what I do is I write these two vectors as the rows of the determinant. And you want to expand this determinant. Now, like some people, they freak out, right? They freak out and they go, what is a determinant, bro? I don't even know. Well, there's two reasons, I think, for having determinants being useful in these calculations. Number one, it makes it easier and you don't have to remember a formula, right? But moreover, in this course, when you do matrices, which is one of the last topics, you will do determinants, okay? You will do determinants of matrices. So just start it now. Yeah, thanks. So how do you do it? Well, let me just define what a determinant is. And I'm glad that some of you see it. Okay, if I have a 2 by 2 determinant with these sort of straight lines, you multiply diagonally. So this is a definition now. Okay, that times that minus that times that. Okay, and with this 3 by 3 thing, what you do is you start up in the left-hand corner and you play a little game that I like to call cover up. Okay, it's called cover up. And I've just lost my Sharpie. Oh no, there it is. Okay, so you can play along at home, everyone. You start with the top left-hand corner, okay? And you realize that I is in the first column and the first row. So you cover them up, right? And then you multiply I by the determinant of what's left, what you can see. So 2 times 2 minus -4 times 3. And then you move on to this one. That's in the middle row and the top column. And you multiply j by that times that minus that times that. Okay, and you then move on to the k. Multiply k, that times that minus that times that. And the only thing you need to worry about, every time you move from I to j to k, you change the sign. So it goes positive, negative, positive, negative. Okay, so let me show you how it works. And you can do whatever works for you. Okay, this is how I'm going to do it. Okay, so the first thing is, it's I times the determinant of what you can see there, the 2 by 2 determinant. Okay, and then you move on to the j. It's j times the determinant of that thing. Okay, but you change the sign, so it's a -j. And the last thing, you get onto the k, and it's k times that. Okay, go back to the same sign. Okay, so you can use this definition of a determinant up here now to work out these determinants, right? So 2 times -2, oh, hang on, oh, that should be a +2, right? So that one's coming from there, so that should be +2. All right, so 2 times 2 minus -4 times 3. So that is just 4 plus 12 times I. Okay, this one, 0, that times that, minus that times that. So that's minus -4 times 1. So that's 4, and there'll be a minus sign out there, right? So it's 0 times 0 minus 4 then. 0 minus -4. Okay, and last one, that times that, which is 0 minus that times that. Okay, so that's it. If you want to write it as a column, because I know some people prefer to write things as a column, that's it. Okay, yep. So there you go. That's one way of doing it. And if we go back to GeoGebra, so I'll come back in a minute. Did somebody say GeoGebra? You can see that this black long normal vector is actually consistent with our answer. Okay, you can see that. Okay, so let me go back. Now, as you can see, I missed a sign there, and then someone said, "Hey, what about that?" So just be careful when you're doing this, right? Like obviously you want to pay attention and not make silly mistakes like I do sometimes. All right. Now, let me know on the chat, everyone. Is this the way it's done in lectures, or is it a different way? Can someone sort of clear it up for me? So is it done? So it's a different way. Oh, use the formula. Oh my goodness, the formula. Who can remember the formula? Well, when I when I'm giving these classes, usually I say, don't remember the formula, because the formula, it doesn't really mean anything to me. You get this massive mess, right? And you don't have a formula sheet in your final exam, but because you're doing your exam on Maple TA, then maybe it's different. Okay. Hi, Alex. Welcome. Yeah. Plenty of other ways to do it. Plenty of other ways to do it. Okay. Let's have another look. Okay. So I'll go back to question 16 now. So this is a H question. Oh no, it's a H question. H means hard, but I'll just do a simple one of these, right? These properties, they can be helpful in understanding other problems, right? So you can use these little identities to help you solve bigger problems. Okay. So, you know, for the first, I mean, some of these are very easy to prove, but they're a little bit tedious. Okay. So what I might do, I'll do part A, and then we can look through what the other parts mean. Okay. So the first one is a vector crossed with itself. A vector crossed with itself gives you the zero vector. Okay, so let's actually prove that, and you know, we can talk about some of the other ones. Okay, so this is 16. Oops, 16A. So let's consider A cross A, and I'm just going to work that out using the determinant method, and that's how I would do it. And then you just expand it, right? So you start with I, and you move along the top row, and so I is in the first column in the first row, so it's I times I multiplied by that times that minus that times that, but that's zero. And then you move on to J, that times that minus that times that. That's zero. And then that times that minus that times that. That's also zero. Oh my goodness. The zero vector. Okay, so that's pretty easy. That's pretty easy. So let's have a look at the other parts, because I think they're worth discussing. Let's have a look. Okay. So part B, we already looked at that in the GeoGebra picture, right? It basically tells you the relationship between A cross B and B cross A. They're negatives of each other, and they point in the opposite direction, okay, essentially. So that's one thing. In part C, this sort of tells you that if you're crossing a vector that's been stretched by this lambda, then the cross product is also a vector that gets stretched by lambda. So like a scaling thing. And part D sort of tells you, well, you've got a distributive property with the cross product, so you can expand it like you would normally. Zach, so how would you prove it? How would you prove C? Okay, so good question. So you could just do it using part A, but instead of what I've written, you could use, you would put something like lambda B1, lambda B2, lambda B3 in terms of your determinant, okay? And make sure that so you work out the left-hand side, and then you work out the right-hand side, and you show that they're equal. Yeah, exactly, Zach. I think I don't think there's any really deep logical path here. I think you're just basically grinding out the expansions. Okay, let's have a look at 17. Okay, so cross product can also be used for area. Yeah, so not only does it give you a normal vector to two other vectors, you can also use it for area. And so in this question, we want to find the areas and the normals to the planes of the following parallelograms, okay? So let's start with part A. You've got two vectors that form the sides of a parallelogram, and they're not the parallel or opposite sides. What is the area of that parallelogram using cross products? Okay, so we'll go back to this. Let me share my document camera. Here comes my Chrome tab. And let's summarize the question. So this is 17, part A. All right, so I'm just going to draw us a real simple sketch here. This isn't sort of accurate or anything. I'm going to put one corner at the origin, and I'm going to have the other four corners here. So let's consider this. And I'm going to let B be the first point, and D be the second point. Okay. And the question is, how do you compute the area of this thing? Okay, well, you've got that vector there and that vector there. They're just the position vectors in this picture. And we know that the area is equal to B, sorry. The length of the cross product of the sides. So you take that vector, and you cross them together, and you find the magnitude or the length. Okay. So we know what these things are just because you can think of them as position vectors. So let's work out the cross product, and then we'll find its length in a second step. So I'm going to go back to the determinant way of working. So we're going to write these as rows, and then I'm just going to expand it. Okay, so one more time. We start up the top and we move along the top row. So we start with i's in the first row and the first column. You cover those up and you multiply by the determinant of what's left. Okay, then you move on to the J and then the K, alternating the signs as you go along. Okay, so it's going to be 12 minus 4. I'm alternating the signs. 1 minus 0. Sorry, 1 times 4 minus 2 times 0. So 4. And 1 times 2 minus 3 times 0. So okay, and you can write that as a column if you like. All right, last part of the question. The area is this. So how do you compute the length of a vector? You square the components add them together. Okay, so 64 plus 16 plus 4, and 4 times 21, so 2 root 2. So you could talk about that in terms of square units. Okay, so not a difficult question, but here are a couple of ideas for you to think about. Here I've got OB cross OD. Does it matter if I do OD cross OB? Does it matter if I switch them around for the area? I'll get to your question in a second, Adam. So does it matter if I switch these around for the area? Okay. Does anybody know why it's not? Okay, so Zia says no because it's squared. Yeah, Dharam, we take the magnitude, right? So yeah, I think that's what you're getting at. So it doesn't matter which way you do it here because obviously we're taking the length later. Yeah. All right, so Adam, why is J negative? Okay, so the J is negative to, like, when you do this cover up and expand with the determinants, the negative there makes sure that you can do that expansion. And it's consistent with the formula that you saw in lectures. So it's basically just for consistency. And so it actually gives you the formula that you want through the determinant expansions. So I hope that makes sense. What we're doing with the method that I'm showing you, we're expanding these as determinants. Those determinants are defined a certain way. You've got to fit that definition with the definition of that really long, nasty definition of the cross product. Does that make? I hope that makes sense, right? When I used to give these lectures in like face to face, people would stand up and go, "Professor, you are wrong. That negative sign is wrong." Even on YouTube now, some people do it, and then I have to explain, well, because we're using determinants, we want to match it up, and putting a negative sign in there makes us do that. So yeah, that's why we do it. I'm loving the chat and I'm loving all the questions. Okay, I go to some tutorials where people are sort of hanging back, and I don't get that that sense here. All right, let's do one more, a quick one, and I can show you what's going on now. I think in lectures, have you seen, just confirm or deny, 2 root 21, Marley? 2 root 21 square units, 2 times root 21. In lectures, have you seen scalar triple product? Scalar triple product, does that ring a bell, anyone? Okay, because, all right, so I'll have a quick look at a question from that section, but I know you haven't finished this section altogether. Okay, so what have I got here? 26. All right, 26. So show that the 4 points, A, B, C, and the origin with these vectors are coplanar. All right, so first of all, what does coplanar mean? What does it actually mean, right? When we're reading questions, we have to understand the words in them. Who can tell me, what does coplanar mean? Hit me up in that chat. What does coplanar mean? They lie in the same plane. Yeah, it's a spin. Marley, you're absolutely right. It's a spin on collinear, right? So instead of lying on the same line, they lie on the same plane. And Liam's sort of a step ahead here with his comment. You're absolutely right, Liam. If 4 points are coplanar, then the box that sort of connects those points has volume 0, right? So let me show you how it all works. Let me share my screen with you. Go back to my document camera. So many. Like what I need is some hotkeys, right? Like I need some hotkeys so I can go quickly. If I'm on here, I can go like this pretty quickly, right? I can say, hey, then I can go back. But the other switching is very annoying. So it's like clunk, clunk, clunk. All right. So, all right. So 26. Yeah, Marty, you're right. It would be a square. 2D all the way. So we've got 2, 1, 3. We've got 4, 1, 2. We've got 6, 1, 1. And we've got the origin, right? So that's an O. And I'm going to put little zeros in here. Yeah, Julia, I need that. Send me a link if you have any suggestions for hotkeys on camera switching. Send me a link, right? So let's consider this. There's a little theorem that says these points are coplanar if this following. Oh, sorry, I'll do OA there. This triple product, scalar triple product, is 0. Okay, so basically you've got a cross product and then you take the dot product. Okay, now if you take the absolute value of this, it gives you the volume for this parallel pipette or this box, right? But we're actually wanting to show that it's 0. So how do we do it? Well, let's consider our old friend from this morning, the determinant, not with ijk. Now we put in the vector components that are out here. So the bottom part stays the same with this cross product, but instead of ijk, we just put these things here. Okay, so this will be OB, and this will be OC. And the method is exactly the same. Start up the top left-hand corner. Just do the cover-up game. Multiply 2 by the determinant of what's there. Then move on to the 1. Multiply 1 by what's there, and then 3 by what's there. And you change the sign. You alternate the sign as you go along. Okay? All right. So that's how you do it. So it's going to be that minus that. 4 minus 12. That 4 minus 6. Okay, so you add those up and you will get 0. All right. So you can make a conclusion, hence points are coplanar. Okay. George, you've got a question. Got your hand up. If your hand's up on purpose, feel free to turn your mic on or make a comment. So there you go. And now if that wasn't 0, then you'd get some number, right? And the absolute value of that will give you the volume of the box with these points in it. Okay. All right, thanks for your suggestions, everyone. So George, do you want to come forward? We're at the end of the tutorial now. So if you've got something to say, maybe turn your microphone on or just lower your hand. No, it's George No, sorry, Lachlan. No, you're fine. Okay, I know some people sometimes they press the button and they don't want to. I will check out auto hotkey, Daran. Thank you. I'm opening that in a new tab now. You can see here, I've got that one. Oh, have I got that one? No, I haven't. I've got that one. Hey, I don't know which camera I'm on. Just thanks for watching, everyone. And thanks for being part of it. I really enjoy Monday mornings, and you guys make it more interesting. And I know it's math, so it's a hard sell sometimes. Just enjoy the day, enjoy the week, and I'll see you same time, same place next week. Next week will be a calculus one. And enjoy the day. We've got no one's commented on the spider yet. I don't know if anyone's into Minecraft, but my kids love him. And yeah, we will see you next week. Feel free to join us for Choose Your Own Adventure. I'll sign off. Have a great day.